Hi everybody, back with another quick video about linking the Math Learning Center's Fractions app to some of the fractions concepts progression. So we're in part whole fractions, thinking about fractions as parts right now within wholes, and maybe now starting to think about transitioning parts within wholes to parts out of wholes. So the last activity we looked at was doing some partitioning where we had a whole and we were asked to cut off one piece if we were sharing it with 3 people, or what would that piece look like if we were sharing it with 5 people. And then part of the thinking was, how can we prove that we've created equal sized pieces? And one of the things we saw there was maybe we could copy that piece and then use it almost as a measure to see whether we had the right amount of pieces. So this activity that I want to talk about today is something called connected numbers. So what we would ask students to do is create a bar, and it can be any length, but shorter is better for this activity. And once we have a bar, we'd say we were going to call this a 1 bar, for example. Now, we would ask students to make a bar that's twice as long as this. So couple options, right? Like a student might copy what they have and then say, okay, this is twice as long, so we'll call that a 2 bar. And then we would say, okay, now I would like a bar that's 3 times as long. Now, students have done this sort of thing where their 1 bar is no longer visible, then I would want to point out to them that, okay, you have a 2 bar, but we also need to see the 1 bar. So we would want them to we want them to have a situation where all the bars are visible. And the reason for that is because we're hoping that as we ask kids to make bigger and bigger connected numbers, they might start to think about iterating. So they might start to think, okay, next thing I need is a 3 bar. So if I take my 1 bar and I copy it 3 times, that will get me a 3 bar. So this 3 bar is 3 times as long as this 1 bar. Then another thing you might talk about with students is, okay, I want a 4 bar, but how could I make it? Yes, we can iterate our 1 bar, but we could also, for example, select all of our 2 bar and copy that and copy it twice, because a 4 bar is twice as long as a 2 bar. So I could get my 4 bar that way as well. All of this idea of iterating these pieces, as well as talking about twice as big or 3 times as big, is starting to set some of the foundational work for what we're going to do later with fractions as measures. The other thing it does is it helps you tie in a little bit of their multiplication knowledge, using that language of times as many or times as big. That's an important thing. And then one other thing you might do, and this would work in a little bit of structuring number as well. If I make my 5 bar like this, a question I might ask a student is, what are all the different ways that you could make a 5 bar or a 11 bar, depending on how far you get and what level of student you're dealing with. So if I copy my 5 bar, maybe could I think of 3 different ways to make a 5 bar? So this might be additional thinking that a student could do if they need a challenge, or it could be something that the whole class thinks about. But if I want to make a 5 bar, I could just take my unit, my original bar, and I could just copy it 5 times, and that could be a 5 bar. Or maybe I think of this 5 bar as a 2 bar, and then I copied a 3 bar. So that would be another way I could think about the 5 bar. Or maybe another way is maybe I think of it as a 1 bar and a 4 bar. So that's not all the ways that we could do it, but that's some of the ways we could do it. A further challenge would be, what are all the ways we can do it, and how do you know you've found them all? Okay, so hopefully that activity is a again, helpful in helping us think about fractions within holes, but moving toward fractions outside of holes and supporting the fraction progression. See you.